good afternoon, and welcome to Science Colloquium here at Modesto Junior College. Thank you for joining us today. Today we are going to have Colleen Naughton from UC Merced talking about tracking COVID-19 utilizing wastewater, and we will begin that talk today at 3:15. I do want to tell you about some upcoming events. The Modesto Area Partners in Science series is going to be continuing on November 19th with Dr. Steve Farmer, and he is going to be talking about the chemistry of common candy ingredients like carmine, chicle, and confectioner's glaze. And if you want to pick up some candy before the talk at the Great Valley Museum, they will have candy with those ingredients available for you to get before the talk. And that talk will be Friday, November 19th at 7:30 p.m. I do want to also mention that our last talk for Modesto Area Partners in Science will be Dr. Margaret Turnbull from the University of Arizona and SETI Institute, also NASA Ames, on Friday, December 10th at 7:30 p.m. And also this talk will be on about having another Earth and the search for life beyond Earth, especially looking for intelligent life. And to sign up for these events, MAPS has a sign up. If you go to mjc.edu/instruction/SME/MAPS, you will find the virtual event sign up. If you go to the MJC page and just search SME and MAPS, you will find this also pretty easily. So you add your name and your email address. They will send you back a reminder before the event along with the link to the event. For Science Colloquium, this is our last talk today, and we will be back for spring of 2022. We have a talk on orchid evolution for our yearly Darwin Day talk. We will have another talk on the birds of Merced National Wildlife Refuge, and also a talk on vernal pool ecology. So we will have a series of 4 to 5 talks in the spring, and we will be publishing that schedule here on the Science Colloquium channel. So you can check back for that schedule in the next few weeks. All right, I'm going to hand things over to Denise today to introduce our speaker.
Okay, thanks, Liz. Okay, so Dr. Colleen Naughton is an assistant professor in civil and environmental engineering at UC Merced. And she initially got her bachelor's degree in civil engineering from environmental concentration from Purdue University in 2008. She's got a very interesting background, by the way, so you'll find out. She was part of the Peace Corps Master International Program, where she served and conducted research in Mali, West Africa for 3 years as a water sanitation hygiene engineer. She received her master's in science and civil engineering from University of South Florida, Tampa in 2013, and obtained her doctorate from the same university in Florida in 2016 in the Department of Civil and Environmental Engineering, where she was also a postdoctoral researcher. She completed over a year with a Science and Technology Policy Fellowship through the American Association of Advancement of Science in Washington, D.C., with the Millennium Challenge Corporation. At UC Merced, her lab co-designed sustainable and culturally sensitive food, energy, water system for and with the underserved nationally and globally through the life cycle analysis, geographic information system, integration of anthropology and engineering and effective science policy. He served on the Water Quality Monitoring Council, COVID-19, Wastewater-based epidemiology committee, which I'm sure she'll be talking about. He recently joined a team led by Dr. Joan Rhodes at Michigan State University and funded by the Bill and Melinda Gates Foundation that has developed a global data center for wastewater and SARS-CoV-2. He's originally from Royal Oak, Michigan. Neither of her parents attended university. He enjoys endurance events like marathons and triathlons. He has completed 2 full triathlon, Ironman triathlon. He also enjoys cross-stitch, reading, hiking, and moving. So I'm going to turn this over to Colleen. Dr. Naughton.
Yeah, thank you so much, Denise, for the lovely introduction and for having me on this science colloquium. I really appreciate it. So hopefully everyone can see my screen. If not, let me know. So today I'll be talking to you about using wastewater to track COVID-19. Not sure how your level of knowing tracking the virus in wastewater, but you'll learn a lot more through this. Just a full disclosure, everybody poops. We'll be talking a lot about poop today, but I find it fascinating and a way to learn about chemistry, biology, engineering, and even geometry. So today, Denise asked me to talk about my career path a little bit and then environmental engineering careers before getting into what is wastewater-based epidemiology and our global dashboard, COVID Poops 19, of wastewater tracking in universities, sites, and dashboards across the globe, as well as our recent project, Healthy Central Valley Together, where we are monitoring wastewater for SARS-CoV-2 at Modesto and Merced wastewater treatment plants, and will expand to 6 more treatment plants in the valley, and a global data center, the one Denise mentioned, funded by the Bill and Melinda Gates Foundation, to try to create a global repository of all this data that we're getting from tracking in wastewater. And a question I'll ask throughout is like how the pandemic has changed the water sector. The pandemic has changed much of our lives, but it also has changed the water sector in some good ways. It's been an unfortunate and continues to be an unfortunate pandemic where lots of lives are being lost, but it has created some room for some innovation, science, and growth, and then leave time for acknowledgements and questions. So introduction, you heard a little bit about me. I'm from Michigan. I am married to a Californian, so I'm getting to know California very well and calling it my home now. And so I was raised by a single mom. I saw my dad like most Saturdays, but I felt like I was raised by a village, my grandmother and my 2 aunts as well. My mom was a grocery store bagger at Meijer. That's our version of Raley's in Michigan. And my dad worked loading and unloading trucks at Coca-Cola. So when I went to undergrad at Purdue, I wasn't able to call my parents like other people were about asking questions about help for calculus or physics homework. So that was a little difficult. So if you're a first generation college or one of the few people in your family to go to college, I understand the difficulties. I never imagined getting a PhD. It kind of, luckily I had a lot of opportunities and it came this way. But we did struggle growing up, lower income family. My mom, we got behind on rent sometimes. It's colder in Michigan, would have the heat turned off and electricity. She was on like food stamps and didn't want to be, worked full time and worked really hard. But it's difficult to have, a living wage for that type of job. So had a lot of assistance, a lot of help from our local church, and had a lot of people support me throughout my life. And I've had a lot of privileges. I've never had to experience racism. But it was a difficult path, but you can get there and even get to a PhD. And so I went to Purdue, which is in Indiana, for undergrad. It's one of the top 10 engineering schools. I was good in math and science in high school, so they recommended I do engineering. I didn't even know what that was, but they said that you solve problems, and I wanted to help solve some of the problems. I was in Model United Nations in high school. I was a real dork, I guess, and I realized the disparities, not just within the United States that I experienced, but hearing about others that can't even get water to drink or food to eat. And so I wanted to really help others like others had helped me. And I do like running. I was in cross country and track in addition to marching band in high school. And then I started doing marathons and then triathlons in graduate school. So an Ironman is a 2.4-mile swim, 112-mile bike, and a marathon at the end. So keeps me in shape. I'm not as good or motivated as people are just to exercise on their own. So I like to sign up for races, and that gets me motivated to train. So it has been a little difficult in the pandemic and kind of gained that COVID-19 or close to it, but did my first half marathon for a while a couple weeks ago. You heard more of my bio, or it's online. Yeah, I went to Purdue for undergrad, went to University of South Florida, all the way in Florida for graduate school. And so my family visited me more in Florida than when I was in Indiana when it was only 6 hours away. But the Florida program had this Peace Corps Masters International program where you combine both your service in the US Peace Corps, which is, if you don't know, a 27-month service in a low or middle income country in need. And so I was a water and sanitation engineer in Mali, West Africa from 2009 to 2012. So there's some pictures of me planting a tree at my going away ceremony. And then after I graduated with my PhD, I did a science and technology policy fellowship, and then I worked with the International Development Agency, Millennium Challenge Corporation. So those are the pictures on the right, ones with a geothermal, like a cooling tower for groundwater in Tunisia. So we were looking at date farming and how to improve the water efficiency there. They were farming dates in the desert, and it's coming from very deep wells that are actually like very hot. So they have to have these cooling towers before they use it for irrigation. But some of them are, as you see here, kind of falling apart. The rebar is exposed, probably shouldn't be standing that close to it. And yeah, I got to ride a camel for the first time in Tunisia. I also did projects in Morocco with mapping for community, like giving land titles for communal lands. On the bottom is like working in a well. We were lining a well in Mali for greater protection so it doesn't cave in, and also prevention from contamination from, say, a latrine or from animals. So I've had a lot of great experiences in travel and opportunities throughout my life. And so at UC Merced, decided to stay in academia. I loved teaching, I loved research and travel, so I felt it was a way to keep combining the two. And so my research focuses on food, energy, water systems for and with the underserved in the United States and globally. I like to work on a lot of different things and like at the intersection of food, energy, and water. Today I'll be talking more about water and wastewater, but I also do other research looking at different crops and their life cycle environmental impact, and looking at water treatment and quantifying just, the energy involved in different processes. And there is something for community college transfers. If you are transferring to or considering going to UC Merced, I am the principal investigator or project lead on a U.S. Department of Agriculture research and extension experiences for undergraduates program. And it's along the theme food and agriculture, cyber informatics tools, and science. So this is a 6-week summer research intensive program that you'll get to, we go on field trips every Friday to different farms and food processing facilities, and you're integrated in like professors' labs even before you go to campus to get to know them before you start in classes. And we have workshops on life and university skills, to creating budgets or adjusting to university or UC level classes. So it's a great program. I encourage you to attend. The applications are due May 1st, 2022, or spread the word. Well, it'll be the second year of the program. We had the first year last summer, the first in-person summer program since COVID-19. So we've gotten a lot of the kinks out. So the second year I think will be even better. So getting into briefly some environmental engineering careers. If you don't know what environmental engineering is, it's a branch of engineering. It has three different kind of pillars where it's protecting human populations from adverse environmental factors, so like hurricanes or flooding or droughts, and then protect the environment from natural and human activities. So we help with wetland restoration, for example, and then improving environmental quality. So it's about humans and protecting humans, but also protecting the environment. All my degrees were in civil engineering, which is environmental can be a subset of civil engineering, but I was emphasized in environmental. So civil engineering, you may be more involved in structures and buildings and skyscrapers and transportation, roads and bridges. Environmental engineering deals with water treatment, wastewater treatment, but they're closely linked together. There's a lot of overlap that can be in renewable energy, sustainable energy, like solar panels and other things. So there's different environmental engineering careers, not just the academic or professor one. I never envisioned going into the academic track as far as this one, but really enjoyed teaching and research and what I was doing. But by far, most people go into other tracks like government, consulting, industry, or construction. I did do the Science and Technology Policy Fellowship in Washington, D.C. We need more engineers and scientists in policy. It used to be in the single digits for those in Congress and in the Senate. We're getting a little higher representation, but it's good to have more of those people in government and even working at, you can work at state or local agencies as well as federal agencies like the Environmental Protection Agency. Consulting can work for different companies that do infrastructure projects or improving roads or building bridges or and there's a big infrastructure bill that just passed, so there will be a lot of work for people. And you can go more into industry, which is like working with different firms that have like laboratories or manufacturing different products. And there's, construction work, actually doing site management, and on the construction site, there's a lot to do there in coordinating materials and supplies and building things that need people. And engineering pays well. That's also part of the reason I went into it. Pays a bit better than some other disciplines. And it's really, you're a problem solver, as I said. So even if you go in civil or environmental engineering, you may go into more mechanical or industrial project management. So it's really easy to move like around once you get that skill set. So these are kind of the different tracks where, as I'm more entry level into academia. I guess I'm in the middle now, like as an assistant professor. If I hopefully get tenure, then move to associate or professor, can be like a dean of a college, can even get up to the chancellor, or provost, or university president role. Same for government. You could be a head of an agency, even president or vice president one day. So there's these different tracks. So in industry, you'll have like entry level engineer, and then you'll move up, and then you can be more in senior management and project management. And same for construction, but more based on construction site. And then for consulting, one of my friends, Stephanie Paredes, we went to the University of South Florida together, and she did Peace Corps in Panama, and she's working with AECOM now and does a lot of projects. So just design and in consulting, you can be more involved in construction within consulting, or also just be designing. I think she was designing like this treatment, water treatment plant. She was designing some of those components, and she was working on sewer systems. And so you can also move along that track and even become the CEO or president of that firm one day as you move along your career. So hopefully that helps give you a preview of what the possibilities are in engineering. So getting more into wastewater-based epidemiology, or using wastewater to track COVID-19. If you haven't heard of it before, everybody poops, so everybody's shedding the virus, and when you flush the toilet, it usually goes to a wastewater treatment plant. It might go to a septic tank or something that's on site that might be more difficult to test. But usually it goes in the sewer system and goes to a treatment plant. So we're not discharging right into the environment or into the river. There's like certain regulations for that. But then we do shed COVID-19 like virus SARS-CoV-2 in our stool. Like 40 to 80% of people shed. And it's not a fecal oral, like primarily not a fecal oral virus. So you're not getting the virus from your stool. It's primarily respiratory aerosols and droplets that is transmitting the virus. But the virus will be in your stool. There has been live virus isolated from very highly infected patients, but once it gets inactivated pretty quickly once it gets into the sewer system. So then you can take a sample from the wastewater treatment plant, and that sample can be representative of like hundreds or even millions of people, depending on the size of the treatment plant. I think Los Angeles treatment plant, Hyperion, is like very large. And so that sample can be kind of representative of that population. You can also sample within the neighborhood scale or like within the sewer. So that will be representative of that neighborhood that you're sampling from. And people have been sampling at dormitories or other buildings as well. And so this is not a new method or technology. It's been around even for tracking poliovirus and vaccination levels. It's been around a few decades actually, but the public has become like a much more common during COVID-19. So I'll constantly see like articles that are like new and novel technology, but it's been around for a while. And so they started adapting the methods for wastewater-based epidemiology for the specific virus SARS-CoV-2 right when the pandemic like started in like February and March. So Italy was one of the first places to have, outside of China, to have a large outbreak, and where their hospitals were really stretched then, if you remember from the beginning of the pandemic. And so they started monitoring there. I think in the Netherlands was one of the first places, and also Australia. And then there's a lot of people that were working on it within the United States. So a part of wastewater testing, it can track like community levels, but it also can be potentially an early warning system, because people shed in their stool that are asymptomatic, not showing symptoms, or they shed early before they become sick. And so by the time you go get a test and get those results a couple days from now, you could grab it from the sewer or from the wastewater treatment plant, and that's like there within a day. And so that can be, you can get a higher concentration of the virus before you start seeing the clinical cases tick up a bit. And also those asymptomatic shedders eventually spread the virus to other people that become symptomatic. So you might have higher people shedding, they don't know it, that are asymptomatic, and then they spread it. So you'll see a higher signal, like they're seeing like 5 to 6 days. It's anywhere from 2 to 14, or sometimes, depending how well your clinical testing is, it'll follow the cases. And so the University of Arizona is actually, they've been doing wastewater testing for different viruses for a long time. So they were able to like estimate that they thought there was 2 students that were sick from their wastewater sample, and then they tested the whole building and they found 2 students. So they had a really developed system. So every sewer system is different and has like, you're flushing more than just feces and urine, or there's other water or other things in the system. So it can be kind of difficult to predict or like say this is this many cases. Or you don't know how many people are shedding. But if you have a good understanding of your system and you've been monitoring for a while, you can become pretty confident in those numbers. And so there's been used widely at the city level, like Ottawa and Ontario and Canada have been using it. And California is like one of the leaders, like one of the most amount of sites testing in the United States. So wastewater-based epidemiology can be like technically cheaper, because one sample on the right is like a large population compared to like an individual clinical test for one person. So you can get like more bang for your buck for one sample of wastewater that you're taking through about the same process. Of course, wastewater testing should not replace clinical testing. It's like another tool in the toolbox, but it could help you target clinical testing. Like we could test the dorms on campus, or they do at others, where they test like 6 or 7 dorms and they get like a signal, and then they're like, oh, we should really test this dorm and have a ready test instead of making everybody test every day, which can become expensive. So in the right upper hand corner, if my face is not over it, you can see that the virus is like fragmented a little bit more, so it degrades. So it is detecting the RNA, like different fragments over time compared to more like of a whole virus. And so this is like a workflow for how the testing actually works. And there's different variations. People are using a number of different methods, and people test the wastewater as well as like only test the solids. And so you get the sample from the system, and then you like concentrate it. You might use a filter to do this over like a small filter, or you might use nanobeads or like a magnetic sort of process to concentrate the virus. And then you'll extract it and use a polymerase chain reaction to like look at the RNA. And you can also like quantify how many genome copies per liter there are in your wastewater. So it's looking at specific genes on the like SARS-CoV-2 RNA, not like the whole strand, but specific genes that are representative of the virus. And so some of you may be familiar with the Johns Hopkins University dashboard for COVID-19 cases. It's a really good global dashboard of what's going on. Unfortunately, we reached a grim milestone a few days ago with over 250 million cases and 5 million deaths. Luckily getting pretty high, like 7 billion vaccine doses now. But I was thinking when this first happened, when Johns Hopkins had their dashboard, like what if we had an early warning dashboard with wastewater? And I didn't really see like a lot of people tracking wastewater on a dashboard like this. And I'm on Twitter a lot, so that's why we have the @COVIDPoops19. But I saw a lot of people were starting to test the wastewater, so I wanted to kind of serve during the pandemic. I kind of felt a bit helpless, and what can I do to help? And so that was the best way I found to be able to help, was using my background in wastewater treatment and mapping. So we created our dashboard through looking at, Twitter. As I said, I do daily keyword searches. I've done it for over a year and a half of 6 different combinations of wastewater and COVID-19, sewage and COVID-19, and SARS-CoV-2. And I look at the peer-reviewed literature. There's a Google form at the bottom of the dashboard, and we were going to webinars and still do at like all hours of the morning, because me and my students, because it's global. So times in Australia and Asia are very not always convenient for the West Coast. And there's a Slack channel of COVID-19 Wastewater-based epidemiology collaborative that also posts a lot of things. And we only post like public information or news articles. We don't grab from webinars without people's permission. But then we filter based on if it's a dashboard or there's data available for the wastewater, if there's which university or institution, number of countries that are monitoring, and number of sites. So we just reached over 3,000. I need to update this, in 58 countries and 270 universities. And we have a preprint that talks about our methodology. So I use ArcGIS Online dashboards. So this is closer for the dashboard, and we have like over 3,000 followers. I know it's not like the Kardashians or some very famous singer or movie star, TV celebrity, but I think 3,000 for a poop channel is pretty good. And we follow a bunch of people that are monitoring, and like it's also the general public follow us, and we just retweet like different articles about people monitoring, and when they have awards or when they have like increases in the wastewater, to kind of keep it aggregated in one place and keep people informed and like create a community. And so our dashboard, we launched it in September 2020. It took us a while to do all that filtering initially and get it on the dashboard and design it so it's like relatively user friendly and like has only a few colors and using good design practices. And we are still a bit US centric, as you can tell, like we do get a lot of the US points, but now we're over, we've over doubled our countries in a year. and lots of dashboards, and we added sites, which we have a lot and just reached over 3,000. My student, Clara Medina, so all this work, could not do it without my students, is spending tons of time trying to find treatment plants and sites in like these locations. It's a lot of work to do the dashboard. So at least if, one student doing 20 hours a week, I'm doing at least 20 hours a week. And the Johns Hopkins University dashboard, it employs about 100 people to maintain that. So we're kind of a lean, mean machine for this COVID poops dashboard. I have some other students doing research credits, but she made a California version of the COVID poops dashboard, and there's a QR code for the link to that, as well as the data center, which I'll talk about in a little bit. And so she mapped there's about 384 wastewater treatment plants in California and 48 sites testing. I think we're now to like 13 universities, and there's like 9 dashboards. But California, you couldn't see as much from the dashboard. There was like a lack of monitoring in the Central Valley. It was more in coastal areas and southern areas, like 38 and 33%. About 21% of those monitoring was in Central, and a lot of that's in Davis. That's doing also sewer shed monitoring. That's driving up that number. Very few in Northern California, though it is a little less populated. And California has this classification system for disadvantaged communities with like poverty, language disparity, and like environmental justice layers. And so about 10 of those monitoring for SARS-CoV-2 and wastewater were in disadvantaged communities, so only about 11%. So really trying to draw attention to some of the areas that lack access to clinical testing and to even to healthcare. Central Valley, we don't have very much good access to hospitals and such, and have lower vaccination rates. We also have lack of access to this testing, but that is changing now. UC Berkeley is monitoring in Fresno recently, and we're starting to expand to 8 treatment plants. So that's what we're calling Healthy Central Valley Together. This new project from some anonymous donors through UC Davis. They had Healthy Davis together and Healthy Yolo like County together. So Dr. Heather Bishel is the lead of this team, and I'm helping with the Merced and Stanislaus treatment plants. And we have some students as well. So we are in phase 1, onboarding the facilities. As I said, we started with Merced and Modesto just a couple weeks ago, so I'll show you some data from that. And we became recently a joint center of excellence from a National Institute of Health funded project through Ceres Nanoscience. So that uses the nanobeads and magnetic bead technology for concentrating the virus. And Dr. Allie Boehm at Stanford, Krista Wigginton at University of Michigan, and Marlene Wolf now at Emory University has a SCAN project. So they're monitoring in 9 different treatment plants and 1 sewer shed that has a dashboard that'll show. So they're the ones that started Merced and Modesto early. We were originally going to start in January. So luckily they've been able to onboard Merced and Modesto so that we start monitoring. So we have the signal before the holidays, which I think will be a good for tracking community spread. And then we're developing a toolkit. So it's not enough just to monitor the data, but it's also disseminating the data. And we meet with public health departments for how we will use the data. And so phase 2, we will expand to 4 more treatment plants, at least in Merced, 2 more treatment plants, 1 in Merced and 1 in Stanislaus, and 2 more treatment plants in Yolo County. And so we're monitoring about 4 to 7 days a week. It's good to monitor like at least 2 days a week to get actionable data and for that early warning. And then we're also hoping to sequence further, not just for SARS-CoV-2, but influenza and other like pathogens to track in the wastewater, since COVID will be used beyond this. And yeah, so this is the Modesto treatment plant. Screenshot if you don't know where it is or what a treatment plant looks like from aerial view. This is my grad student, Kristen, on the top, where we'll sample. I think there's a tap lower down that they sample from the primary clarifier. That's Ben Kohler. He's the head treatment operator at Modesto treatment plant, and there is a need for wastewater treatment plant operators, and it does pay well, and they don't all go to 4-year degrees, and there's going to be a lack of them. There's going to be more treatment plants than operators to operate them, and it's really important for public health and environmental health. And so we sample for the sludge for the Healthy Central Valley Together project from the solids. So if you don't know, this is like a really quick wastewater treatment, like 101, but you gotta like get out the big like toilet paper or like the non-flushable wipes first. And then you kind of like get out the grit. There's like sand and everything else. And then you like settle it, like let the solid settle a little bit. And then you move it through biological treatment, which you aerate. So that picture before with Ben, he was at an aeration basin. So there's microbes that degrade, the matter, the poop and everything, and even organic waste. People use your garbage disposal. So that's food for the microbes, and then they degrade pathogens as well. And then you settle it out again. And then you deal with the solids. There's different ways to treat the solids, whether it's like solar drying, there's anaerobic digesting, putting it like in a closed system, and that can produce methane and energy. You can also, once the solids are dried and pathogen free, you can apply it to the farm. So Modesto has some person that they lease to that farms, and they put the solids for usually crops that are consumed by animals, not necessarily by humans, or there's very specific crops. And they do discharge probably to the Tuolumne River after it's treated. So it will probably go, I think they do UV disinfection as well, like a tertiary treatment step. So this is the Merced and Modesto data. I've been trying to monitor these treatment plants for 1.5 years. So it's really exciting to me. So it might not be as exciting for everybody else. But wb.stanford.edu has a dashboard. You have to scroll down for Merced and Modesto, but these are screenshots. So it's the grams per, so it's the genome copies so of these different genes. So they monitor the S and the N gene per gram of dry solids. And then that's normalized over like the genome copies of pepper mild moldovirus, which is a fecal indicator. So people eat peppers, and it's like a virus that's not, bad for you. Not all viruses make you sick. So it's normalized to the fecal strength because wastewater has, infiltration, like like the pipes might have leakage in them. People are putting food down their systems, or there's industrial discharge that's not just human feces. So to get an idea of how many people are contributing, you can do this based on a fecal indicator, which is this pepper virus. So they normalize the genes per this fecal indicator, and you can graph it over time. They also look at the Delta variant, like a gene for the Delta variant for how much of percent that is making of the system. So Merced is the highest of all of their treatment plants. Modesto was a little high in the middle. There's a comparison chart. They also have a video on the website if you want to learn more about the methods. It's like 11 minutes. And so there was a spike, and it seems to have gone down. And the health department said that did coincide with some of their clinical data as well. So we'll keep monitoring it. But when you see a spike like that, you usually want to be like, maybe target some more testing or some more public health messaging, like more indoor masking and such. So you can see the data. Modesto, I thought, is in purple. So you can click on the different plants that they monitor, and you can see the data. So you see Modesto is kind of in the middle. Merced was high, which is unfortunate. They do have low vaccination rate and higher community spread. So we'll keep monitoring over time. The last thing I wanted to talk about, so I've got like kind of 3 projects going on, but they all overlap. I have the dashboard, then the wastewater monitoring in the Central Valley, and now this like global like repository of wastewater data, wastewater SARS public health and environmental response, WSphere. And so sphere.waterpathogens.org. Since we saw from the dashboard, there's a lot of places monitoring, and we want to put this data all in one format, hopefully, and display it and like keep it for the future. And eventually moving towards like any like future pandemic or other virus monitoring, how we can do that better in the future to coordinate and maybe have more of a global like dashboard with the data. Because right now my dashboard is like points of who's monitoring and you still have to click to go to the data. So this is the mission of WSphere to advance environmental surveillance of sewage to inform local and global efforts for monitoring and supporting public health measures to combat disease. It's a huge partnership. Merced's just a small part. It's led by Dr. Joan Rose. She won the Stockholm Water Prize in 2016. She's a microbiologist at Michigan State University, the person that got one of the first papers and research on monitoring SARS-CoV-2 in wastewater, Dr. Gertjan Medema at KWR Water Research Institute in the Netherlands. Ventec Technologies is the one really doing a lot of the website design and dashboard design. And PATH is a global health equity nonprofit. And so part of this data center, we're also doing monitoring in more low and middle income countries. So similarly in California, where we have a lack of monitoring in the underserved areas of California, it's still, most of the monitoring is done like 30%, 20 to 30% in, is only in low and middle income countries. Most of the monitoring, like 60%, is done in high income countries. So similarly, that there's a lack of access to vaccines in low and middle income countries. There's a lack of access to this testing. So we're doing testing in Ghana, Pakistan, Bangladesh, Malawi, and integrating those data sets as well. And then we have public health like use cases for examples of how people are using the wastewater data. And so this can help others get ideas of how to use the wastewater data, or if they haven't been monitoring the wastewater, like why they should or what they could do with it. So this is our data flow. And so we kind of mine the data from COVID-19 dashboard, and we look at just the dashboard points because not everybody is publishing their data openly. And we look at those points and then we download their data and put it in a uniform template. And we also request data from people, or people want to contribute data to the data center. And then we import it into the system. We use ArcGIS Online dashboards and a web repository for the data. So currently we have like the 97 data points or dashboards from COVID-19, and we've integrated data from 24 countries, over 20,000 samples, 668 sampling sites. So we have 12 data sets, and we're hoping to get more by the end of 2021. Still working on them. It's just a lot of like going back and asking for like different data, because not everybody says the population data or like how they're monitoring or their methods. So we have to go back and ask people for their limit of detection of the virus and other things, so that we have all the information we need. And so this is the data center, and there's a global map that you can click on. So similar to COVID Poops, but more focused on the data. And so you can click on these different dashboards. So the green dashboards are the ones that have all the information we want in the template that we have. And then there's the yellow ones, which may be lacking some information, say on population, or they're only having if the virus is present or absent, not like the quantity. So those are ones that we're looking to get the final data for the full data set, but we still have some that we can display. And the gray ones are future ones that we'd like to request data from. And so you can click on any of these points and you can go to the website of the dashboard. So that's the more current information. We update the data about monthly. We have automated places like Scotland, which I've heard that some of our coordinators have family there. They have one of the best dashboards. I probably shouldn't say that or be too biased, but they have a lot of great data that's well updated and that we can like automatically update from their site. And then you could go to view sites and I'll show a more close-up of that, but we do have a snapshot of how many sites are monitored, how many samples, if they're monitoring like in the sewer, or if they're monitoring at the treatment plant, or some are monitoring in rivers or like environmental waters, and when sampling began. So if you click the view sites button, you'll see the different sites they're monitoring, and the size of the bubbles is based on the population that they're monitoring from to kind of show the signal. So presence of the virus is in red and green is absence. And you can play with the dates. So over time, Scotland's add more sites that they're monitoring from. So you can kind of see over time, and you can see if it's present or absent and how the signal has changed maybe over holidays. And you can go to a trends view. And so you can also click on each individual site and you can see what gene they monitor, like the population, like the average quantity of the virus and the maximum that they've detected. And so this is the trends view. So it's not just red or green, it's an upward or downward arrow or like a slight decrease or no change. If you can see, it's the log transformed like normalization over the past 5 samples. So we look over the past 5 samples they've taken if there's going to be increasing concentration. So you see on the right-hand side, if you're seeing that increasing, then that's probably going to be a arrow that's upwards. And if it's decreasing, the opposite or just stagnant. And so you can also do the trends view over time as well for this data. And yeah, so then you can also, if you don't want to go on the geospatial view or the map view, you can go to the data and you can search different data sets, whether they're monitoring regionally, nationally, or at the building level. And you can type different countries or US states or cities and see if they're in there. So we have 12 data sets now, so usually you can kind of just scroll through, but we hope to have a bit more so that the search function will be useful. And you can contribute your data if you have data to contribute and fill out a form. And if you click on an individual country, you can download the data and then you can see some of these like more snapshots of like how many sites, how many samples, and the gene target. And then the final part is the use cases. And so we have 2 up now. We're adding some more soon from Switzerland, and I think New Mexico is monitoring at correctional facilities. So you've seen a lot of increase in cases, unfortunately, at correctional facilities, but they can use the sewer data to monitor that as well. And so if you click on one of the use cases, there's the Dutch surveillance case. So they used wastewater testing to identify areas, and they put up mobile testing sites. So they saw an increase in the wastewater. So they're like, okay, we're going to put out a mobile testing site. And they like text message, or they have signs like increase signal, like in wastewater, like get tested if you're not feeling well, or some just like get tested, like even asymptomatically to test and try to see and contact trace where it's coming from. The Catalan surveillance network in Spain covers, I think, 80% of their population. So they also use the data to target clinical testing. They also use the data where they don't have as much access to clinical testing to see where the signal is, or like where there might be increases in signal. So these are like pretty easy, like brief, not like a dense text, and there's lots of pictures. So it's kind of a way to get a good summary of what they're doing. So this is more, not as many of you may be involved with wastewater monitoring for SARS-CoV-2, but if you know someone, you never know, and would like to become involved, we're just calling on everyone to contribute their data, whether they're utility laboratory or public health department, and follow us on Twitter, the COVID Poops 19, or waterpathogens.org. So WBE beyond COVID. So hopefully one day we're beyond where COVID is really stressing our hospitals and a lot of people are dying. It might become endemic, more like the flu. So we may still need to monitor, but as I said, wastewater-based epidemiology was used before for poliovirus. It's been used for hepatitis A, like rotavirus, adenovirus. So we could create, now that we have a lot of these people trained, a lot of students are becoming trained, a lot of universities are doing this, we could have a global network that monitors for other pathogens, or even using sequencing to maybe prevent the next pandemic moving forward, or at least detecting it early. And there's a silent pandemic going on with the antimicrobial resistance. And so this can also be monitored in the wastewater. So this may be important moving forward to also look at the spread of antimicrobial resistance. And so some main things that I've seen on Twitter throughout the pandemic is the US has the national wastewater surveillance system now. The European Union has their own surveillance system as well. And Canada has like a network of laboratories. So we've really created these sort of regional and even countrywide monitoring networks that we can build upon. And then just seeing US politicians talking about wastewater more, it doesn't always get a lot of attention that I think it deserves, since it's very important just for, as I said, public health and the environment. Like engineers have prevented more illness than, say, individual doctors with water treatment and wastewater treatment. Not that doctors aren't important, they're more focused on the individual, but engineers have really helped, like initially with cholera and other pathogens, about making us healthier and living longer. And so even governors were talking about wastewater testing, or that they needed more of it. There's been some fun videos in Australia. The Australians are pretty hilarious, and just like they've seen increased signals between their provinces, and they're like blaming, like, oh, someone from your province came over and pooped in my province, and that's where it's coming from. It's not our people. I mean, it is a really difficult time, but there's good that we can find some humor in all of this. And then I think this is what my parents think I do, poop inspector. He's just one of there's like a Facebook video celebrity, and he was making fun of the Australian poop inspection, since they have a very robust wastewater monitoring program that they've used to even like close borders and such. And so, yeah, the pandemic has really changed the water sector, just as you saw initially, like how many people have become involved in countries in monitoring wastewater. There's a greater collaboration. There's like weekly meetings at a lot of these places. Like we're having meetings with the public health departments, and you have the wastewater utilities coming, and cities and policymakers all coming together that didn't really talk to each other as frequently. So this is beneficial for other things, not just for COVID-19, since water is health. And then creation of these national, regional, and global monitoring networks and databases. So that's most of those are the things I majorly wanted to talk about. Of course, I want to acknowledge everybody that contributed to the data center and all our partners and all the students at UC Merced and the institution. And this dashboard was originally funded through the Center for Information Technology Research in the Interest of Society from Citrus. It's like a UC center of 5 different universities. So we couldn't have started without that funding, like an emergency COVID grant. But yeah, I look forward to questions, and you can always email me and also follow us on Twitter or visit all the websites. But thank you again for this opportunity. I hope you learned a bit more about wastewater and wastewater monitoring and how it can be useful. Thank you.
Thank you so much. That was a terrific talk. I hope our public health locally is monitoring some of this data, because it's really amazing looking at that Modesto and Merced data and that little uptick at the end of October. I was glad to see it go down also. Hey, just really quick on that data set, what website was that on?
Yeah, wbe.stanford.edu.
Okay, that was that one.
Yeah.
Awesome. Yeah. I'll put that in the notes for people to see. I added your Twitter to the chat just so people could quickly link. So if anybody wants to link in there, they can check that out. And we do have a couple of questions. One question from Richard Anderson. Do you have an example, perhaps like the University of Arizona dorms, where discoveries in your program have generated a medical action that's helped to combat COVID-19? And he does also add that you mentioned the Catalan example, but other examples also.
Yeah, no, that's a great question. Yeah, a lot of universities have used it to find cases. So they've seen an increase in the wastewater not just University of Arizona, but I mean, UC San Diego has a whole dashboard and they actually have color code their dorms based on if there's increasing or decreasing signal. So that's like really useful. And I'd love to have that at UC Merced in all campuses, but it can be expensive and a lot of work. Catalan, like there's tons of examples throughout the US and Canada and Europe where they a lot of times use it to target more testing. Some of them have like found, because you can monitor the variants, so that they were able to find like the first detections of the Delta variant and even before with the Alpha with the British or the UK variant. So they're able to kind of see that, oh, we got a case like that. So sometimes they do trigger like more lockdowns because of wastewater signal, but a lot of times it's more targeting public health messaging and access to testing, or some have even used it to target like where they'd need to put vaccine clinics and sites. So there's been a lot of good examples, and some of them, if they get into the sewer shed monitoring within the city, you can see, which city, like especially they've been using it on, as I said, in correctional facilities, but also in Native American communities as well that have less access to clinical testing and healthcare. So they've been able to use it in some of these underserved communities.
It's really valuable. And it's like the small little rainbow during all of this is that this is expanding and then can be used for tracking other diseases in the future, other viruses, looking at flu. I can think of so many like ways that you could just utilize this, that it'd be very valuable going forward, not just right now and maybe whatever, hopefully not, but if there's another pandemic in the future, maybe we'll see it early in wastewater. Other questions? I just wanted to thank you for mentioning some different environmental engineering careers. That's great for our students because they're always trying to figure out, I know I want to be in science, I know I want to be in certain disciplines, and they see another path, and there's a lot of careers here that they might not readily think about without these examples. And one thing I kind of thought of is you showed the Scotland data on the map. I'm kind of wondering if our climate change conference here that's going on, if we'll see any upticks. Hopefully not. So if you guys aren't aware, the climate change conference is going on in Glasgow, Scotland right now, and hopefully we'll get some good climate change policy from that. I'm just giving that a plug. And then I wanted to ask you, what is the start date? You mentioned the summer undergraduate research engagement in food and agriculture. When would the start date be for that?
Yeah, I think we're starting around July 11th. Might be July. It's after the 4th of July. So it's 6 weeks starting after 4th of July and then through mid-August.
Okay, great. I received an email during your talk about it, and I'm going to send it out to students and to our division, because what a terrific opportunity. So thank you so much today. I'm going to just double check. I think I have all the questions. I do want to ask you one more thing. We leave these talks on our Science Colloquium channel. Are you fine if we leave this up?
Yeah, of course.
Yeah, we'll get a lot more views over time, and it's great for our students to get to check it out. So I want to thank you, and everybody, we'll be back in the spring for our Science Colloquium series. I hope you join, check out the MAPS schedule and join us for the next one of those. And I'm gonna let you guys go. I hope you have a terrific weekend.
Yeah, thank you so much for having me.
Bye.
Thanks, Colleen.